Okay, so in this video, I just want you to focus on how to set up dividing functions, and we'll focus more on talking about the domain. So if I want to do f over g of x, I'm just going to take the f of x function and divide it by the g of x function. So I want you to try the g over f of x. But the reason we do this is that when it's set up, we can state the domain. So what can our x's be and not be, and that way we can evaluate it. So let's say someone asks us, well, what is f divided by g of 3? Well, all that means is I've set up my f over g function, and now I'm going to substitute 3 anywhere I see x. And so 3 minus 2 is 1, 3 squared is 9, minus 4 is 5, so 1/5. That's what I want you to do as far as dividing goes. The more important thing, as you try setting up g of f and evaluating it for some number, is to focus on domain. Now, pretty much any time that you're working with functions, your domain, as you've noticed when you're dealing with just equations and graphs, is going to be all reals. So all real numbers, or not -8, negative infinity to infinity, pretty much every time except for 2 exclusions that we're going to talk about. The first is if you have a square root with an x inside of it. The second is if you have x in the bottom of a fraction. If you remember from Algebra 1, x cannot be negative inside of a square root. We can't have a negative number in there because that gives us imaginary domains, and so, no real numbers. And then in the second instance, x cannot be 0 in the denominator of a fraction. 1 over 0 gives us undefined. So imaginary and undefined. So those are the restrictions on our domain. So if you're going along and you don't see a square root symbol with an x under it, or you don't see an x in the denominator, then it's going to be all reals pretty much every time. So let's go back and take a look at this. So I have f of x equals square root of x, and g of x equals 4 minus x squared, all under a square root. You can see that square root has already come into play, and when I set up my f of g function, so square root of x over 4 minus x squared, now I've got x in the denominator of a fraction, and I've got x under a square root. So we're going to have some restrictions on our domain. So let's check it out. Well, I know that x can't be negative. The reason I know x can't be negative is because if it were negative, then that would make that non-real. So x has to be greater than or equal to 0, because it can't be negative. So we also need to look at down here. What would make this negative? Well, 4 minus anything bigger than 4 would give us a negative number. And so basically x has to be smaller than 2, because 2 squared is 4 and 4 minus 4 is 0. So x has to be greater than or equal to 0, x has to be smaller than 2, and that will keep us from having any negatives inside of our radical symbols. Because if x were 3, 3 squared is 9, 4 minus 9 is -5. That's a no-no. So now, the bottom here, we'll do a different color. The bottom here cannot be 0. The bottom of a fraction cannot be 0. So let's just set up an algebraic equation. The square root of 4 minus x squared equal to 0. Let's find out what value of x is equal to 0. We'll square both sides. 4 minus x squared equals 0. We'll subtract 4. Negative x squared equals -4. Divide by 1, or -1. X squared equals 4, take the square root, x cannot equal plus or minus 2. Because if x were 2, 2 squared is 4, 4 minus 4 is 0, square root of 0 is 0. That makes it undefined. If x were negative 2, negative 2 squared is 4, 4 minus 4 is 0, square root of 0 is 0. That makes it undefined. So now we have to put this all together to write our new domain, our restriction. So x has to be bigger than or equal to 0, and it has to be less than 2. So the fact that it has to be bigger than 0, we can cross off the negative 2. And it can't equal 2, so that we basically know that x has to be less than 2, and it has to be bigger than or equal to 0. That is our domain of that function. And so I know that seems kind of difficult. You'll get better at it. You just always got to think, if I have a radical, what does x have to be for it to be negative? Because that would create a restriction. And if there's an x in the bottom of a fraction, what does x have to be to give me 0? Because that would create a restriction. So we'll do practice problems on this. I'm going to do one more example. I'm going to flip it and do g of... Actually, we'll save that one. I'm going to come down here and look at our restrictions for this problem that we did earlier. So, are there any restrictions on the top? No. There's no radical, and so I don't have to worry about negative numbers. Any number I pick in the world, I can substitute in for x and get a real number. So I don't have to worry about that. But now look at the bottom of the fraction. It can't be 0. So x squared minus 4 cannot equal 0. So if I add 4 to each side, x squared equals 4. If I square root both sides, x cannot equal plus or minus 2. And so that's the restriction on my domain. So x is all real numbers, except that x cannot equal plus or minus 2. Because if I had negative 2, negative 2 squared is 4, 4 minus 4 is 0. If I had positive 2, 2 squared is 4, 4 minus 4 is 0. And I can't have 0 in the bottom of a fraction. So that's working with the domain. If you have any questions, let me know.